In this class, let us discuss some 2-3 problems on hydrostatics. In the last video, I have explained about the concepts of hydrostatics, about the total pressure force and location of center of pressure, all those things. Now here, the problem runs like this. A circular plate 2 meters diameter is submerged in water such that its greatest and least depth of immersion are 3.5 meter and 2 meter respectively. Find the total pressure on one side of the plate and the depth of center of pressure. So figure is not given. So to analyze the problem, first let us try to draw the figure. So it is water here. So free surface of water is like this. A circular plate is immersed in water, but here he has given whether it is vertical or inclined, we don't know. That we have to decide based on the data given in the problem. So he has given that the diameter of the plate is 2 meters, greatest and least depth of immersion are 3.5 and 2 meters. That means, suppose if it is immersed vertically, so you have to understand here. So this is the free surface. Suppose if it is vertical immersion, the greatest depth is this, the bottommost point of the plate, that is the greatest depth, 3.5 meter, and the least depth is this one, that is 2 meters to the top edge of the plate. He has given the diameter here, diameter is like this, it is 2 meters. Now if you take it as a vertical plate, you can observe here that, so this greatest depth value is 3.5 meter, whereas if you take the other way, the least depth and the diameter, it becomes 2 plus 2, 4 meters. That means these two are not equal. So when these two are equal, then it is a vertical surface. Since they are not equal, the other chance is it should be inclined. It should be inclined. So it cannot be vertical plate, it should be an inclined plate. Now if you draw a figure of inclined plate like this, we don't know the angle theta with which that plate makes with the free surface. Let me take that as theta as it is unknown. And if you draw the figure, least depth is 2 meters. So AB is the plate now. A is the top point, top edge, and B is the bottom edge. Least depth is from the free surface to point A. Greatest depth is from free surface to point B. So this is 2 meters, this is 3.5 meter. A diameter of the plate, it is read like this. It is 2 meters. D is the diameter of the plate. Now the center of gravity of the plate, we know that it exactly lies at the geometrical center. And center of pressure always lies below center of gravity, somewhere here. At that point, your total pressure force will be acting normal to that. So at right angles to this. Now this is the diagram. Now x bar is the depth of center of gravity of the plate from the free surface. H bar is the depth of center of pressure from the free surface. P is the total pressure force. And your projected area, this whatever water is there, that is exerting pressure on this entire area of the plate. That area of the plate you can see here is pi d square by 4 since diameter is d. Now we have seen the formula for finding P and H bar in the last class. So for the formula to find out total pressure is gamma W into A into X bar, because water is there here in this problem. We have to take gamma W. A is the area of that plate over which that pressure is acting, and X bar is the depth of center of gravity from the free surface. Now if you find out these three things and substitute, we can get the value of P. Now we know that gamma W is specific weight of water is 9.81 kilonewton per meter cube, or 9010 newton per meter cube. I will take 9.81. The answer of P what we are going to get will be in kilonewton. Now the thing is, since it is an inclined plate, we need to calculate the value of theta. Of course, for this you don't require theta. A we require. A is pi d square by 4 for this circular plate, which you are getting it as pi by 4 into 2 square, that is 3.14 meter square is the value of the area of the plate. And the x bar from the diagram you can see, to calculate x bar, of course, you need to find the value of theta. So to find the value of theta, I will take this diagram, it is a triangle. So I will take the plate like this. It is making an angle theta with the free surface. Since this is theta, this becomes theta. You know that the diameter of the plate is 2 meter. So to the center of gravity it will be 1 meter. And this distance will be now the difference between 3.5 and 2. So greatest depth minus least depth, 3.5 minus 2 will be 1.5. So this vertical distance AC will be 1.5. Now in this right angle triangle, if you take sin theta is opposite side by hypotenuse 1.5 by 2, which is 0.75. So we got the value of sin theta as 0.75. Now you apply that rule for the smaller triangle. So for the smaller triangle, if you take here also sin theta will be so 1 divided by y. So this is unknown. This we have to find out now. So sin theta will be y divided by 1. So y divided by 1. So therefore y will be equal to sin theta. Sin theta we have got it as 0.75 here. Therefore the value of y will be 0.75. So now if you want x bar will be, it should be measured from the free surface. From here to here it is 2 meter. From here to here, this is y I have taken. So this y we have found as 0.75. So 2 plus 0.75, 2.75 is the value of x bar. Now once you get that x bar, now you can just substitute the value here in this formula. You will get the total pressure. Gamma W is 9.81 kilonewton per meter cube, and A value is 3.14 meter square, and x bar value is 2.75 meters. So please note that this is kilonewton per meter cube, this is meter square, and this is meters. So if you multiply these three, you are going to get the value in kilonewton. So kilonewton, that is the total pressure force exerted by water on the circular plate, which is normal to the plate. So which attached at right angles to this plate. So this is how we can find out the hydrostatic pressure, the total pressure. Now to find the depth of center of pressure, that is h bar, we have to use this formula for inclined plate. So h bar is x bar plus ig sin square theta by ax bar. In this, you know all the values except this ig. Ig you can calculate. So the formula for circular plate for moment of inertia is pi d power 4 by 64. D is 2 meters here. Substitute and simplify. You will get 0.785 meter power 4. That is the unit of moment of inertia. Now once you get this value of ig, substitute here and simplify. You will get h bar. That is depth of center of pressure. That is from here to here. From here to here. The value is 2.8 meters. You can observe here is x bar is 2.75 meters, whereas h bar is 2.8 meters. That means always center of pressure lies below the center of gravity. H bar is always equal to x bar. So this is how we can calculate the total pressure and center of pressure. Now in the second problem, I have taken a triangular plate. Triangular plate, we observe here that the base of the plate coincides with the free surface of oil. So instead of water, I have taken oil of specific gravity 0.9. If you know the specific gravity, you can always find out the specific weight. So specific weight of oil is given by specific gravity of oil multiplied by specific weight of water. So 0.9 into 9.81 kilonewton per meter cube, because gamma W is 9.81 kilonewton per meter cube. So gamma of the oil becomes now 8.829 kilonewton per meter cube. So same formula we are using here to calculate the total pressure. P is equal to gamma oil into A into x bar. So A here is area of this triangular plate, which is half into base into height, which is half into 4 into 4. These dimensions we have given, which becomes 4 meter square. And x bar is the distance of the distance from the free surface to the center of gravity. So in this case, center of gravity lies here, so which is nothing but 1/3 of this total height. So 1/3 of 4, 1.33 meters. So now you know the value of gamma, oil, A and x bar. So substitute in this, you will get the total pressure as 8.829 into 8 into 1.33, 94.176 kilonewton. That is the total pressure exerted by this oil on this vertical surface of triangular plate. Now to calculate h bar is the distance of the center of pressure from the free surface, which is this value, which is once again given by, since it is a vertical plate here, So the sine square theta term will not be there, or that will be equal to 1 because theta is 90 degrees. So x bar plus Ig by Ax bar. So you have to get the value of Ig here. So for a triangular plane, Ig is given by BH cube by 36. This formula you should note. So BH cube by 36, base is 4 meters, height is also 4 meters. 4 into 4 cube by 36, which you are going to get 7.11 meter power 4. Now substitute all those values here. X bar here is 1.33 plus Ig 7.11 divided by area is 8 meters square into 1.33, you get 2 meters, approximately 1.998 something you are going to get. You can take it as 2 meters. So here also you can observe that X bar is 1.33 whereas H bar is 2 meters. So H bar is greater than X bar here also. So that is the total pressure and the depth of center of pressure. Now the same problem what I do is, all the other things keeping the same, what I do is I will take the apex of the plate lies at the free surface of Y. So apex instead of base, here base of the plate is coinciding with the free surface. Here apex of the plate, vertex of the plate is lying at the free surface. Then this is the diagonal. So in this case the values will be different. So X bar value is different here. All other values remain the same. You can see here. So gamma of oil is same 8.829 kilonewton per meter cube. Same oil I have taken. X bar value, this is the X bar value. Center of gravity lies. Now I have to measure the location of center of gravity from the apex, which is 2/3 of 4. Here it is 1/3. Please note, it is one from the base. It is 1/3. From the apex or vertex it is 2/3. So 2/3 into 4 meter. So that becomes your X bar value, which is 2.67. Double of that, 2.67 meters you are going to get. Area of the plate remains the same. Half into base into height, half into 4 into 4, which is 8 meters square only. So now in this case, the total pressure is given by P is equal to gamma of Y into A into X bar. Only this X bar value will change. So you are going to get 188.584 kilonewton. And coming to this center of pressure, depth of center of pressure, X bar plus Ig by Ax bar. So here also X bar is 2.67, Ig remains same, A remains same, 2.67. If you simplify, you get 3 meters. Here also you can see X bar is 2.67 meters, whereas H bar is 3 meters. So H bar is greater than X bar. So just by orienting the position of the plate, same plate, but here it is base is coinciding with the free surface. Here it is vertex is coinciding with the free surface. Please note that the distances X bar and Y bar, H bar and Y bar, H bar and X bar, they are measured from the free surface. If it is coinciding with the free surface, then from that point only we have to measure. So this is how we can solve problem on inclined surface and vertical surface. Like that, they may give rectangular plate, they may give semicircular plate, they may give. So I have given the expressions for finding area and moment of inertia. So other things you have to draw a sketch, and you should be in a position to write that find that X bar and Ig we have to find out. Then gamma normally they will give, and area of the plate you have to find out. So area of the plate is nothing but area of that lamina. So if it is rectangle, D to D. If it is triangle, half into base into height. If it is circular, pi d square by 4. If it is semicircular, pi d square by 8. Whereas moment of inertia values, if it is rectangle, it is bd cube by 12. If it is triangular, it is bh cube by 36. If it is circular, it is pi d power 4 by 64. If it is semicircular, pi d power 4 by 120. So these formula, if you remember, in addition to that, so gamma into A into X bar gives the total pressure. X bar plus Ig by Ax bar gives the location of center of pressure in the case of vertical surface. In the case of inclined surface, H bar is given by X bar plus Ig sin square theta divided by Ax bar. If you know all these things, any type of problem you can solve.